Hello all, today in this video I am going to provide details regarding Gaussian NP with heart disease detection dataset. Already with this work we have worked with many other different machine learning algorithms and also naive Bayes. But in this code we are going to work with the three different types of naive Bayes. Already we have worked with multinomial naive Bayes, and here you are going to work with the Gaussian naive Bayes and are going to make a comparison within this multinomial naive Bayes and Gaussian naive Bayes. So this data set we downloaded from Kaggle. You can just give us heart disease prediction data set in Kaggle. In that case, you will get the data set from Kaggle itself. So initially, we are loading the libraries which we are needed for this code. Then we are just importing our data set. So this data set having different 14 features, and it is having nearly 1000 rows. So the 14 features, from this 14 features you can notice that this old peak feature is the only thing which is in float type. All others are integers, and also every feature apart from target we will be selecting as the x variable, and the target one will be selected as the y variable. Then we are getting the info of the data set. Already by we can come to know that before getting the info of the data set, apart from old peak everything or integer, old peak is the float one. Then we are just checking whether it is having any missing values. If it is having any missing values means we have to work with some pre-processing functions, but since it is not having any missing values, this work is not making any pre-processing functions. Then we are getting the shape of the data set, and then the target variable, that is the y variable, we are making a plot that how many zeros and ones are that in that target variable, and that thing we are graphically picturizing. You can note this is the one. Then we are using the determining the x variable by omitting the target, and y variable by including only the target by the use of this x variable and y variable. And the test size is 0.2, that is 20% for testing and remaining 80% for training. We are determining variables like xtrain, xtest, ytrain and ytest. Then already we have worked with the multinomial naive Bayes and have plotted the confusion matrix plot with the text text variable, and also the classification report we have generated with the test variable y test1. For that we have get an accuracy of 75%. Now in this code we are going to work with the Gaussian NP. So with the only difference is the library. So that library function we are calling within a variable. That variable we are using for training and testing. Training is done by use of the fit function, and testing is done by use of the predict function. With training we are using the variables like xtrain and ytrain, and with testing we are using the variables like xtest. Then we are determining a variable like prediction GNP, that is Gaussian NP. This GNP variable we are using to declare the confusion matrix and also the classification report. Here you can notice that we have displayed the confusion matrix. Here we can find that it is showing only 8126, that is the size is very low. Why? Because we are using only the testing variables for to determine this confusion matrix and also the classification report. So only we are getting very less number of things. If you are interested in knowing to compute the confusion matrix with the training variable means, you can do it also. In that case you have to give here as y train. Then we have declared the classification report for this Gaussian NP. For that we have got an accuracy of 84%. Previously for multinomial NP you can notice that we got only 77%, but here we got nearly 84%. Then we have made a comparison between this multinomial naive Bayes and Gaussian naive Bayes. For that we have declared a variable called models. This models we are calling within a loop. Within within the loop we are training the model, testing the model, and then declaring parameters like accuracy, mean square error, R2 square error, and also displaying the training accuracy and testing accuracy of the two models within the single cell. You can notice that the training accuracy of the multinomial Naive Bayes is 75.12 and the testing accuracy is 74.63. Then when comparing with this Gaussian Naive Bayes, the training accuracy is 82.44 and the testing accuracy is 83.90. Then we are making our table. In the table we are making some highlighter that like the model with the best accuracy will be shown with green color and the model with the least accuracy will be shown with less color. Already we noticed that multinomial Naive Bayes is providing less result when compared to Gaussian Naive Bayes. In the next video we can make a comparison with Bernoulli Naive Bayes and we can just confirm that which Naive Bayes algorithm is providing the better result. Thank you.